In this video, we are going to introduce the idea of law of cosines. You use law of cosines and law of sines to solve triangles that are not right triangles. And you have to kind of figure out which situation you have. Do I need to use law of sines or do I need to use law of cosines? I start off by wanting to use law of sines. And if I can't use law of sines, then I shift to law of cosines. So let me kind of give you a rough idea of what this looks like. So if you're missing a side, that means you're going to be you're missing A, but that means you have B and C and you have an angle across from it. So here's what we got going on. So if here's your triangle and you're looking for this value and you don't have those two, that's basically what you would have. This would be, if I'm going to use law of sines, I need to have the angle and the side across from each other so I can create one full fraction for my law of sines. But if I don't have that situation, then I can't use law of sines. So what I'm looking for is, do I have two sides and the angle in between? And that works for a whole lot of them. So if I had that situation, that's also a law of cosines because I can't create one full fraction. I don't know an angle and a side across from it. So that's what I'm looking for. I'm kind of looking for a corner and seeing if I have that information, then I'm going to be using law of cosines. The other situation for law of cosines is I have nothing but sides. So if I have nothing but sides, there's no way I can use law of sines because I still need that one full fraction. I need an angle and a side across from each other in order to do that, which we don't have. We're never going to have, especially if we have nothing but sides. So that's kind of the look for what we got going on. Either I kind of have a corner or I have nothing but sides. And so if I have that information, then I'm going to be using law of cosines. So here's the formulas for it. And there's only reason there's three is because if you're missing side A, here's what it looks like. If you're missing side B, here's what it looks like. But really, they're just kind of, their values are just shifted around depending upon the value that you're missing. But notice that here are your two sides and the angle in between. That's kind of that corner, basically, is what you're looking for. And then the other one is if you know all your sides, but you're missing an angle. So if that's the angle that you're looking for, it's you're subtracting the side squared, and then you're dividing by 2 times the other two sides that you know. Okay, and those two sides are the ones that surround the angle. Okay, so we'll go through a couple practice problems and kind of help get a feel for what's going on. So here is our shape. So we're going to need these formulas. And here's our shape. We do not have any angles, which means we can't set up one full fraction for our law of sines. Because remember that your law of sines looks like this, where you're setting up proportions. And the only way I can use it is if I have an angle and a side across from each other, which we don't have. So I will say that as you're trying to do this, we're going to use law of cosines just one time, and then we can have enough information to shift to law of sines. So I prefer to do that. But we do need to start this process because we're going to figure out an angle measurement, but you need to start with largest angle. All right, that largest angle is going to be across from the largest side. So we're looking for angle B. So we're going to say, we're going to find B. So it's going to start off as cosine of B. So eventually we'll do the inverse cosine to finish it off. But here's our formula. We're going to take A squared plus C squared. Okay, so this would be A because it's across from angle A. So 7 squared plus C squared, which is 5. So plus 5 squared, and then minus the B squared. So minus B squared, which is 8 squared, divided by 2 times the first 2. Okay, so that's just going to give us some decimal. And so we're going to have cosine of whatever that turns out to be. So to be careful with this, I'm going to show two approaches to this really quick, just to kind of show you what your options are, and then I'm going to use what I think is the better of the two. So the not as good of the two is I need to make sure that I use parentheses pretty well on this because I have a whole numerator divided by a denominator. So my calculator won't do this right unless I treat it as a numerator divided by denominator. So I need 7 squared plus 5 squared minus 8 squared in its own parentheses. So that represents the numerator divided by its own parenthesis. If I don't do this, then it's only going to divide by 2 and multiply by the 7 and 5. So now what I want. So I want 2 times 7 times 5, and then do that. Okay. So it's not a bad method. You just got to be careful with your parentheses. So there is our decimal. So 1, 4, 2, dot, dot, dot. So I'm going to hang on to that whole decimal, and I'm going to finish this, and then I'll show you the other route we do. Is my B value, my actual angle, is going to be me doing the inverse cosine of that decimal, but I want to do the full decimal. I don't want to round it to the very end because my calculator is storing this value for me anyway. So I'm going to be doing the inverse cosine of that decimal. And then close the parenthesis. Okay, so that gives me my angle measurement. So angle B should be 81.8. Okay, so that's perfect. That's one of the missing pieces, and we're looking for all 3 angles. The other way on that fraction is you do have a fraction button on this calculator. Most of these calculators have it, not all. So if you hit alpha F1, it gives you that top one as a fraction. And so then you can do your 7 squared plus, and then it just kind of separates it out a lot nicer. Okay, but you should get the exact same thing. In fact, you might actually get the fraction version of that, which is fine. So then you'll do the inverse cosine of that fraction. Okay, so that's kind of your other option on it. So let me label my picture. We have angle B is 81.8, but now look what we just have. We have one full fraction. So we can shift over to law of sines if you'd like. If not, you can do law of cosines one more time, and you just have to adjust your formulas because you'd be using another angle. So now I can do, if I want to, sine of 81.8 over 8. And then let's say we find angle A. So now I would be doing sine of angle A over 7, cross multiply. So then I'd have 8 times sine of A equals 7 times sine of 81.8 divided by 8. Sine of A equals whatever that turns out to be. It's the calculator. 7 times sine, 7 times sine of 81.8 was parentheses divided by 8. Okay, so 0.866 dot. So we're in the exact same kind of situation we were at the last part. We got 0.866 dot dot dot. So in order to figure out the angle one last time, we have to do the inverse of it. So 0.866 dot dot dot. So inverse sine, which is right there, of that, close parenthesis, press enter. So 60 degrees on that one. So angle A would be 60 degrees. And then I am done with law of sines and law of cosines because if you look at the picture, you have 60 degrees here. And I can just do 180 minus the other 2 angles to finish it off. So I have C is going to be 180 minus the 81.8 minus the 60. So that turns out to be 180 minus 81.8 minus 60 turns out to be 38.2. All right, and then I do one last thing. I'll go on my picture. 38.2. And then I kind of just spot check real quick. Biggest side should be across from the biggest angle. Smallest side should be across from the smallest side, smallest angle. And if that stuff lines up, it's a really good chance that I did all this work correctly. All right, so that was an introduction to law of cosines and an example that you had nothing but sides. So we use law of cosines, and then we also shifted over to law of sines to finish off finding all of that.